Hello, everyone. In this video, we are going to go through some common relationships of events. So first of all, we will use a diagram. A pictorial representation of events and manipulations with events is obtained by using a Venn diagram. Okay, here in the diagram, the sample space S is represented by the interior of a rectangle. And any event, say event A, is represented by the interior of a circle. Since any event must be a subset of a sample space, so the circle represented of an event should be entirely within the rectangle. Let's consider an experiment of rolling a die once. So let A be the event that the outcome is an even number, and let B be the event that the outcome is an odd number. So the sample space consists of the number 1, 2, 3, 4, 5, and 6. And then event A consists of the sample point with numbers 2, 4, and 6. And event B consists of the numbers 1, 3, and 5. Let's construct a Venn diagram showing event A and event B. So we will use a rectangle to denote the sample space. So all the numbers from 1 to 6 should be included in this rectangle. And then for each event, we will use a circle for its representation. So here we have two events. So we use two circles, one for event A and one for event B. And then we will start writing the numbers, okay, into the respective circles or the rectangle. Okay, so the number 1 is in event B. So the number 1 is within circle B. And then the number 2 appears in event A. So the number 2 is written within circle A. And the number 3 appears in event B. So number 3 is in circle B. Similarly, number 4 is in circle A, number 5 in circle B, and number 6 in circle A. So this is the complete Venn diagram for this example. Let's take a look at another example. Okay, now let event A to be the event that the outcome is at most 5. And B be the event that the outcome is an odd number. Okay, so write out all the possible outcome in the sample space as well as the corresponding outcome in event A and event B. So A is the event that the outcome is at most 5. So the event A consists of the number 1, 2, 3, 4, and 5. And event B is the outcome corresponds to an odd number. So event B consists of the number 1, 3, and 5. Construct the Venn diagram. Okay, the number 1 is both in event A and event B. So this number 1 should appear in circle A and in circle B. And then the number 2 only appears in event A. So the number 2 is in circle A only. And then the number 3 appears in both circle A and circle B. The number 4 in circle A. And the number 5 in circle A and circle B as well. Not to forget the remaining number, the number 6. Number 6 is not in event A, nor it is in event B. Okay, so this number 6 should be outside circle A and outside circle B. So we have the number 6 here. And then from this Venn diagram, you can see some duplication. The number 1, number 3, and number 5 are both in circle A and circle B. So in fact, we can combine them to reduce such duplication. We can construct the Venn diagram like this. So here the number 1, 3, and 5 are still in circle B. And when we consider event A, okay, The circle A here consists of the number 2 and 4, but not to forget that the number 1, 3, and 5 is also in circle A. So here circle A consists of the number 1, 2, 3, 4, and 5. And circle B consists of the number 1, 3, and 5. And the number 6 here is outside circle A and circle B. And this is the complete representation for this example. Let's move on to the next one. Okay, so here we let event A to be the event that the outcome is at most 4, and B be the event that the outcome is an odd number. Okay, write out the sample space, the corresponding sample points for event A and event B. So event A consists of the numbers 1, 2, 3, and 4, and event B consists of the number 1, 3, and 5. Construct the Venn diagram. The number 1 appears in both event A and event B. So the number 1 is in circle A and circle B. The number 2 in circle A. The number 3 appears in both circle A and circle B. The number 4 in circle A, number 5 in circle B, and then number 6 is outside circle A and outside circle B. Again, we have duplication. Combine them to reduce such duplications. Okay, so only the number 1 and number 3 appears in both circle A and circle B. So the circle B is not entirely within circle A. The two circles overlap with each other. Okay, so this is the complete Venn diagram for this example. So far, we have gone through some common relationships of events as shown on this slide. So in the first Venn diagram, where the two circles has no overlapping region. So here we say that event A and event B cannot occur simultaneously. In the second diagram, circle B is entirely in circle A. So here event A and event B can occur simultaneously. And all sample points in event B are also the sample points in event A. So we can see that when event B occurs, event A must occur, but not the other way around. And then in the last diagram, the two circles overlap as well. So we can say that event A and event B can occur simultaneously. And in this last Venn diagram, at least one sample point is in both circle A and circle B. Next, we will be going through some symbols, okay, corresponding to the relationship of two events. First, we will talk about the union of two events. Let's take a look at the definition. The union of two events, A and B, is denoted by this notation, A and then union B. Indicate the set of all outcomes that are included in either A or in B or in both events. So consider the Venn diagram on the right-hand side, the colored region corresponding to the union of event A and event B. Let's take a look at an example. Okay, roll a die. Let A be the event that the outcome is at most 4, and let B be the event that the outcome is an odd number. So we have the following Venn diagram showing the relationship of event A, event B. So the set of A union B consists of the number 1, 2, 3, 4, and 5. Okay, so in circle A, we have the number 1, 2, 3, and 4. And in circle B, we have the numbers 1, 3, and 5. So these are the numbers to be included in the set of A union B. Therefore, the set of A union B consists of the number 1, 2, 3, 4, and 5. And the number of this set, number of elements in this set is equal to 5. Next, we move on to the intersection of two events. So let's take a look at its definition. The intersection of two events A and B, denoted by this notation, okay, read it as A intersect B, is the set of all outcomes that are included in both events A and B. Okay, so in the diagram on the right-hand side, the colored region corresponds to the intersection of event A and event B. Okay, recall that the intersection of two events is the set of all outcomes that are included in both events A and B. So only the overlapping region corresponds to the intersection of two events in this example. Okay, so let's take a look at an experiment of rolling a die once. Okay, so A be the event, the outcome is at most 4, and B be the event that the outcome is an odd number. Okay, so we have the Venn diagram. So what is the set of the intersection of event A and event B? Only the numbers included in circle A as well as in circle B will be the intersection of the two events A and B. So here, the set of A intersect B consists of number 1 and 3 only. And the number of elements in this intersection is 2. Only the number 1 and 3 are included in both circle A and circle B. So the number 1 and 3 are the only elements in the intersection of A and B. The next definition we are going to talk about is the complement of an event. The complement of event A, it is denoted by A dash, is defined to be the event consisting of all sample points that are not in A. Okay, so here is the Venn diagram. So I use the circle represent event A, and any sample point outside event A is the complement of A, denoted by A dash, the shaded region. Okay, so let's take a look at an example. Suppose you flip a coin. Okay, so you flip a coin, the complement of the event of getting a head. Okay, suppose the event is to get a head. So the complement of the event get a head is the event not getting a head. Okay, so this is the same as to get a tail. Or another experiment, you roll a 6-sided die. The complement of the event obtained the number 5 is the event not getting the number 5. Okay, so these are two simple examples showing the complement of event. So let's take a look at an example. Okay, roll a die once. So let A be the event that the outcome is at most 4, and let B be the event that the outcome is an odd number. So what is the complement of event A and event B respectively? The complement of event A, so let's take a look at what is inside circle A. The number 1, 2, 3, and 4 are in circle A. So the number 5 and 6 are outside circle A. So the complement of A consists of sample point 5 and 6. And the number of elements in the complement of event A is 2. How about the complement of event B? In the circle of B, we can see the number 1, 3, and 5. The numbers 2, 4, and 6 are outside circle B. So the complement of B consists of sample point 2, 4, and 6. And the number of elements regarding the complement of event B is 3. Next, we move on to the definition of mutually exclusive effects. So what is the definition? When event A and event B have no outcomes in common, they are said to be mutually exclusive, or we use the term disjoint. Okay, no outcome in common. So when we draw the Venn diagram, the two circles do not overlap. So here, there's no overlapping region of circle A and circle B. So when there's no overlapping, we say that the two events are mutually exclusive, or they are disjoint events. So the two events cannot occur simultaneously. So the A intersect B is an empty set. No sample points in common. So the number of elements in the intersection of event A and event B is 0. Okay, so far we have talked about the relationship of two events. And we can extend it to more than two events, say 3 or more events here. Okay, so I have event A, event B, event C, and event D. Okay, so let's do some practices. Okay, so I have a highlighted region here. So this highlighted region consists of sample points that are in the complement of event A, outside circle A. The sample point in event B, the sample point not in circle C, so the sample point in the complement of event C. And also this region is in circle D. Okay, so what is the corresponding notation corresponds to this region? So this is the intersection of the complement of event A, event B, the complement of event C, and event D. If we know the relationship in the Venn diagram, we can simplify the notation here. This region can be written as the intersection of B and D. Okay, so let's take a look at another region. Okay, the region in the middle of the circle A, B, and C. Okay, so here this region consists of sample points in event A, event B, and event C, but outside event D. So the corresponding notation would be the intersection of A, B, and C, and the complement of event D. But we can write it as the intersection of A, B, and C as it is shown on the slide. Okay, another region. Okay, this portion. Okay, you can verify that the notation could be written as the intersection of the complement of event A, event B, and event C. And then the highlighted region here, the larger portion. So the notation corresponds to the intersection of the complement of event A, event B, the complement of event C, and the complement of event D. And then we can also confirm that event A and event D are mutually exclusive. Circle A and circle D has no overlapping region. We can also say the same for event C and event D as well. They are mutually exclusive. There's no overlapping region between circle C and circle D. Okay, next we will move on to the definition of collectively exhaustive events. So let's take a look at the definition. A set of events, say event A1, event A2, up to event AN is said to be collectively exhaustive if one of the events must occur. So that is, the sample space S corresponds to the union of A1, A2, up to AN. Okay, so let's take a look at this Venn diagram with sample space S1. Okay, so we have three circles in the diagram, A1, A2, and A3 respectively. Okay, so A1, A2, and A3 are not collectively exhaustive because we can have a sample point outside all these three circles. If we define one more event, say A4, then we can say that A1, A2, A3, A4 are collectively exhaustive. At least one of these events must occur from an experiment. Okay, similarly, for the sample space S2, A1, A2, A3 are not collectively exhaustive. Only when we define A4, where A4 corresponds to the region outside A1, A2, and A3, then we can say that A1, A2, A3, and A4 are collectively exhaustive. The differences between S1 and S2, sample space S1 and sample space S2, is that in sample space S1, A1, A2, and A3 are not mutually exclusive. And in sample space S2, A1, A2, and A3 are mutually exclusive. Let's take a look at sample space S3. Instead of using circles, I used some weird shape, okay, for event A2 and then the triangle for event A1 and A3. Okay, so here A1, A2, and A3 covered all the regions of the sample space S3 here. So we can say that A1, A2, and A3 are collectively exhaustive effects. And similarly for sample space S4, A1, A2, A3 are collectively exhaustive events. And in sample space S3, A1, A2, A3 are not mutually exclusive. And in S4, A1, A2, and A3 are mutually exclusive. Okay, so let's take a look at an example. Okay, suppose we flip a coin 2 times. So I'll define 4 events. So let event F to be the event of getting at most one tail. Event G to be the event of getting 2 faces that are the same. Event J corresponds to the event of getting a head on the first flip, followed by a head or tail on the second flip. And then the last event, event K, corresponds to the event of getting all tails. Okay, so we write out the sample points in all the 4 events. So the sample space here consists of sample point HH, HT, TH, and TT, where H denotes head and T denotes tails. So event F consists of the event HH, HT, and TH, okay, getting at most one tail. So either you can get HH no tail or HT or TH. And then event G is the event of getting 2 faces that are the same. So the corresponding sample point would be HH and TT. And then event J corresponds to the sample point HH and HT. So here the first flip is a head, and then the second flip is either a head or a tail. And then event K is the event of getting all tails. So the sample point in event K is TT. Okay, so let's take a look at the event and then compare the event, whether the events are mutually exclusive or collectively exhaustive. Okay, so let's take a look at event F and G. So are event F and G mutually exclusive? are event F and G collectively exhaustive? Okay, so let's take a look at the event F and event G. Event F consists of sample points HH, HT, and TH, and event G consists of sample point HH and TT. To determine two events, whether they are mutually exclusive, then we check whether there is or there are any sample points in common. So here, the sample point HH appears in both event F and event G. So these two events are not mutually exclusive. Are the two events collectively exhaustive? Okay, so we check whether event F as well as event G consists of all the sample points in the sample space. Okay, so HH, HT, TH, and then in event G, we have the sample point TT. So combining event F and event G, all the sample points in the sample space appears in either event F, event G, or both. Okay, so here event F and G is said to be collectively exhaustive. How about event F and event J? Comparing event F and event J, there is one sample point HH as well as HT in common. So these two events are not mutually exclusive. Are they collectively exhaustive? Okay, so the sample space consists of the sample point HH, which is included in both event F and event J, the sample point HT in event F and event J, the sample point TH is in event F, and then the last sample point in the sample space TT is not in event F, and this sample point is not in event J either. Okay, so F and J are not collectively exhaustive. Okay, how about event F and K? Event F and K are mutually exclusive because there is no sample point in common. And then these two events are also collectively exhaustive. Combining event F and event K, all the sample points in the sample space is either in event F, event K, or in both events. And then lastly, compare the event J and event K. Event J and event K are mutually exclusive. No sample point in common. And event J and event K are not collectively exhaustive because the sample point TH is not in event J, nor it is not in event K. Okay, so in this video, we have go through lots of definitions regarding the relationship of events. Thank you for watching, and in the next video, we will be talking about some concepts in probability.